I believe you are doing really amazing, and welcome to this First Principle Thinking YouTube channel. And in this entire video, I am going to talk about permanent magnet. If you see, almost all the electric vehicle uses the permanent magnet synchronous motor, which looks like something this, right? And if you see the typical design of permanent magnet synchronous motor, it is something like this here, where the permanent magnet buried inside the rotor, and when you applied the external magnetic field through the current, either the permanent magnet get attracted or repelled, and hence it generates a torque. To give you the similar analogy, let's consider a solenoid where you supply the current and it is producing the magnetic field B. Now you bring the tiny magnet, which we call it as a magnetic dipole, inside the field. What happens? This tiny magnets try to align along the B field and it generates the torque. As you can see here, it is aligning, right? And the torque is equivalent to the external magnetic field and the magnetic strength of that magnet, right? And the mathematically it is represented something like this. The torque is equal to mu cross B. Mu is the magnetic dipole moment of that tiny magnet, which indirectly represent the magnetic field strength of that magnet, right? Now, as a designer, I want to maximize the torque production at minimum input. What are the minimum inputs that here I am giving? The current value I am giving, right? To maximize the torque production, I need to utilize the maximum potential of that tiny magnet, which means that I should be knowing a way how to maximize the magnetic strength of that permanent magnet. And this basically motivated me to go ahead and learn about the properties of permanent magnet to maximize the torque production at less input at the less current. So as soon as I started learning about the properties of permanent magnet, I started getting lot of doubts. The first doubt was, what are the remnants and the coercivity, right? The second doubt was, does the size and shape of the magnet affects the remnants and coercivity or not? And the third doubt was, let's say you have kept your unmagnetized permanent magnet in the circuit and you have magnetized it, right? And then it started producing a constant flux, let's say Br, which is equivalent to resonance flux density, right? And then you take out from this circuit and keep it in the air, the magnetic flux density inside the magnet, which was Br when you kept in the magnetic circuit, now it has been reduced. I want you to know why this is happening. The second thing, when you have gone through the BH curve, there you might have seen H is directly proportional to the current value that you applied. In other words, you always have seen H is the external field which are being generated only by circulation of the current. But you will get surprised here. Let's say you have a magnet kept in the air, though you are not applying any external field, still you will be seeing a H value which are going north to south inside the magnet, and outside the magnet it will be aligned towards the B field. And I want you to know why is it happening, why the H field are getting generated though I am not applying any external field. In other words, the material itself generating demagnetization field intensity, and I wanted to know the reason behind this. And to clarify my doubts, I went through the lot of resources. I have read the book Permanent Magnetism, then I have read the book called Magnetic Fields, and then after I have also gone through the book called the Feynman Lectures on Physics, mainly the electromagnetism and matter, where I have read the chapter 36 and 37, which is the ferromagnetism and the magnetic material. I have gone through the book of Concept of Physics by S.C. Verma, particularly the electromagnetism part. And now, since the magnet are being used in the motor, I wanted to know how they are exploiting the properties of the permanent magnet to design efficient motor. And hence, I have gone through the book called Brushless Permanent Magnet Motor Design, and the second book I have gone through the design of rotating electrical machines. So I got the in-depth understanding about the permanent magnets, and the whole purpose of this video is to share that knowledge which I got it. So let's get started.